In this video, we are going to write the equation of the inverse for the given functions. So for our first example, we have m of x equals x squared plus 4 for x being greater than or equal to 0. Now, x squared plus 4 is a parabola, which is not one-to-one. However, because we now have this stipulation for x being greater than or equal to 0, we're narrowing it down and we're saying that this half of the graph does not exist, which is going to leave us with the following type of a graph. Now, our function is one-to-one. We passed the vertical line test and the horizontal line test because of the x being greater than or equal to 0. So now we're ready to find the inverse. So to do that, we're going to go ahead and have y equals x squared plus 4, given that x is greater than or equal to 0. And now we're going to switch our x and our y's. So we're going to have x equals y squared plus 4, given that y is greater than or equal to 0. And now we're going to solve for y. So I'm going to go ahead and subtract 4 from both sides. So I have x minus 4 equals y squared. And then from here, I'm going to go ahead and square root both sides. And that's going to give me that y equals a plus or minus the square root of x minus 4. Now, because we have this restriction, y is greater than or equal to 0, we only want the positive root of x minus 4. So we can then finish up by saying that the inverse of m of x is going to equal the square root of x minus 4 given our restriction. However, because we chose the positive root of x minus 4, we don't need to write our given restriction there, as this takes care of it. So here is our inverse function. So now let's do letter B. Now here, our function f is a one-to-one function, and the graph is basically the same as our graph of y equals the square root of x, right? So something that looks like this, except it's going to be shifted to the right one. So we're looking at, if it was like this, it'd look like that, okay? And so that means we have a domain of x needing to be greater than or equal to 1, and we're going to have a range of where y has to be greater than or equal to 0. So when we define the inverse, we have the conditions that x has to be greater than or equal to 1, and y has to be greater than or equal to 0. So that's when I'm defining the function. So for defining the inverse, we would switch those x's and y's. So let's go ahead and look at that. So we have y equals the square root of x minus 1 with our given restrictions in blue. And when we switch our x and our y value, so I have y equals the square root of x minus 1. So I'm going with the restrictions that the domain has to be x is greater than or equal to 1 and a range of y is greater than or equal to 0. So now I'm going to switch my x and my y, which also means my domain and my range will switch their x and y. So the domain is now that y has to be greater than or equal to 1, and x must be greater than or equal to 0. And now I'm going to solve for y. So I'm going to square both sides, which gives me x squared equals y minus 1. Then I'm going to add 1 to each side. After I've done that, that's going to give me x squared plus 1 equals y. And that leaves me with f inverse of x equals x squared plus 1. But here I have a restriction that I need to write. So I'm going to write, I can write with a semicolon, or I can put it with the word for, x being greater than or equal to 0. And this is necessary for this inverse because f, the function f, has the restriction that y must be greater than or equal to 0. And if we have y equals x squared plus 1, that's not one-to-one without the restriction on the domain, because then it would make our parabola like we encountered in our first example. So you need to have that restriction, or else it's not going to be correct.